So we are going to start off with the first one. We have numbered 64. Four beams of the same length each have three forces acting on them. Which beam has both resultant zero resultant force and zero resultant torque acting? So we can find the forces. We can find the system on which the resultant force is zero, and we can cross out the other ones. So for example, the first one, the total upward force is 80. Okay, we get 80 as the total upward force, but the total downward force is 90. So the resultant force can't be zero. We need to satisfy both the conditions, so A cannot be the right answer. Let's talk about the option C. Let's go for the option B first. So what is the overall resultant force? Is that zero? Let's check it out. 70 plus 36 would be 106. Upward force is 106. Downward force is 106. So it might be the option. So let's skip this one for a while. The last one, option D, 70 plus 42, we get 112. Downward force is also 112, so that can also be an option. And likewise C can also be an option. So we can't rely on the first one only. The resultant force is zero in all three of them. So we need to find the one in which the resultant torque is also zero. So what we can do is choose any point as a pivot. For example, in option B, I'm going to choose this one as a pivot. The middle point I've chosen as a pivot. So the force that is being exerted exactly on the pivot would not be even used in the calculation for moment of force, for torque. Because for that force, the perpendicular distance from the pivot is zero. So you forget about this force. All you gotta do is find the moment of force clockwise and anti-clockwise. If they are equal, then B would be the right answer. How do you do that? 36 times 50. And for the right side, 70 times 30. Now for all these options, you need to figure out for which one of these three you have the moment of force clockwise equal to the moment of force anti-clockwise. For which one of these? And it would turn out that D is the only option in which you have clockwise moment being equal to the anti-clockwise moment. Okay, just hit it on the calculator and you'll sort it out by yourself from here. A minimum torque of 20 Newton meter must be applied to the lid of a jar for it to open. The radius of the lid is 4 centimeter. What is the minimum torque of force? Minimum force F that must act on each side of the lid in order to open it. So for finding the minimum force, we need to use the minimum torque, and you see the torque in that case would be the couple, because you have two forces being exerted. They are equal in magnitude. How do we know this force is F and this force is F? There's no subscript, otherwise it would have been F1 and F2. So these forces are equal and they are exactly in the opposite direction. So that satisfies the condition for the formation of couple of forces. So for the couple, what formula do we have? The formula for couple we have is that the torque equals force times the perpendicular distance between the two forces. Minimum torque that we need is 20 Newton meters. So we do need a torque of 20 Newton meter or a couple of 20 Newton meter. And the force would be written as F. Find the value of F. We write it down as it is, times the perpendicular distance between the two forces. So the radius is 4 centimeter or 0.04 meters. So you have 0.04 meters here. But what is the total distance between the two forces? That would be 0.08. That would be the diameter of the circle. So 0.08. So F into 0.08. And what do you do in the next step? You find it for the value of F, solve it for the value of F, and F equals to 20 over 0.08. Then you hit it on the calculator. Alright, so let's take a look at the next one. A trailer of weight 30. Okay, just the diagram is given. And what is the upward force exerted at X by the cab on the trailer? Upward force exerted at F. There is no resultant moment of force because otherwise your trailer or the cab would have been in rotation. So what we can do is we can apply the principle of moment about any point, and the suitable point would be this one. You can choose this one as a pivot and apply the principle of moment about this point. So this force would rotate it clockwise, and this force that we need to find would rotate it anti-clockwise. Okay, it would move it like this. The 30 kilonewton would make it move like this, clockwise. So clockwise moment equals to anti-clockwise moments. So let's write down the formula. So we have the first one, 30 kilonewton. So 30 times 10, because the perpendicular distance of 30 kilonewton force is 10 meters. Okay, given in the question itself. And the second force is that needs to be found out. We can write it as it is, F times the perpendicular distance of that force from the pivot is 10 plus 10, which is 20. Did not do any conversion. We use the force as it is in kilonewtons, so your answer would also be in kilonewtons. So B is the right answer for this one. 67. Two coplanar forces act on the rim of the wheel. The forces are equally in magnitude. Okay, which arrangement provides or forces provides only a couple? The first one, not this one. The forces cannot be perpendicular, they have to be opposite. B, the forces are in the same direction, they are not opposite. C, the forces are once again perpendicular, they are not opposite. It is the only option D in which the forces are equal, and not only they are equal but opposite in direction as well. So here we have 68. What is the magnitude of the resultant moment on the structure about O? So you need to find the resultant moment, and this is your pivot, the central one. So question itself is not difficult, but it may appear very lengthy. That could be the only problem here. So the thing is, we gotta do it smartly. So first of all, the traditional method is you find the moment of all the sum. You find the sum of clockwise moments after you pick up all the forces that make it rotate clockwise, and then you highlight the forces that produce anti-clockwise moment. Then you calculate anti-clockwise moment, and then you find the total sum of the anti-clockwise moment. Then you find the difference between the clockwise and the anti-clockwise moment. That would be the traditional way, but since we're always short on time, so we gotta do it smartly. First of all, the total length of the rods from here, from the center to at any end, from O to R or O to P or O to S or O to Q, the total length is 1 meters. And the forces that you have in the middle, they are exactly in the middle. They are on the midpoints. So that distance would be 0.5. Okay, so we have the value for the perpendicular distances as well. Well, what you can do is, in order to save time, what you can do is you can cancel out the forces that would produce equal and opposite moments. Cancel forces that produce equal but opposite moment, because for that one the resultant moment would be 0. For example, one of the force here is 20 Newton, and it is 0.5 meters to the left of the pivot. It would produce a moment of 10 Newton meter anti-clockwise. Likewise, the other force on the right side, it would also produce the same moment but clockwise, and then they would cancel out. So instead of finding their moment and then cancelling the moment, what I can do is I can cancel the forces straight away. So these two forces, these are not there. So I'm going to remove these forces from here. These two forces are not there. Okay, so let's check out if there are some other forces that we can remove for producing equal moment. No, we don't have such a case, or do we? For example, you have a 30 Newton force. This one, 30 Newton, is 0.5 meters away from the pivot, and it would make it rotate clockwise, not anti-clockwise, A. And this 30 Newton would also make it rotate anti-clockwise. Alright, plus the 50 Newton force would make it rotate clockwise, and this 50 would also make it rotate clockwise. Likewise, this 70 Newton would make it rotate anti-clockwise, and this one would also rotate the beam anti-clockwise. Okay, just take a look at the direction of the forces. Consider the pivot as a fixed point and try to perceive the motion. That if you're applying a force, if you're pushing down the beam at the end R downwards, what would be the motion of the rod? So let us find the moments. For 30 Newton, the moment would be 15, because 30 times 0.5, 0.5 is the distance. So one of the anti-clockwise, we have 15. This one would also be 15. All right. And what else do we have anti-clockwise? 70. So 70 times 1, because the perpendicular distance of this force from the pivot is 1. So 70 times 1 plus 70 times 1. You can write 140 directly, but I'm going to break it down into steps. 70 Newton meter is the moment of this force, plus 70 times 1, which is once again 70, is the Newton meter is the moment of the other 70 Newton force. So that is all from the clockwise side, anti-clockwise side. What do we have on the clockwise side? One of the force that you have clockwise is 50, and the other one is also 50, and they are 0.5 meters away from the pivot. So 50 times 0.5 would be 25 for the upper one, and likewise 25 for the lower one. So what do you get? 140 plus 30, you get 170, minus this 50, 25 plus 25, 50 would be shifting on the other side, minus 50, and you'll be left with 120 Newton meter. So the answer for 68 would be C. Now the thing is, this question can be done by even simpler method as well. Like, you can combine the forces, you can apply the formula of couple if you have equal and opposite forces, but at this stage I just wanted to break it down so you can understand it clearly. Let's take a look at the next one. A bicycle pedal is connected to a pivot by a metal bar. The force on the pedal is 60 Newton downward. What is the moment of this force about the pivot? So they're asking about the moment of force of this force. So this is your pivot, and this is your line of action of force. Now the thing is, do we have the perpendicular distance between the pivot and the force? Yes, we do. The perpendicular distance is given here, 16 centimeters. We can convert that into meters. So this is the force, this is your force, and 16 centimeter is the perpendicular distance of that force from the pivot. We don't need this distance. This is not a perpendicular distance. This is not a perpendicular distance for the force, okay, because the force is this way and the pivot is over here. In that case, the perpendicular distance would be a horizontal line. So the perpendicular distance comes out to be 16 centimeter or 0.16 meters. So 60 times 0.16. Alright, let's take a look at the next one. Which statement best describes a couple. Forces of equal magnitude in opposite direction will produce a rotational motion but not translation motion. Why not translation motion? Because the force would be, the resultant of the force would be zero, so the net force would be zero, but the net moment of force is not zero. So this option is in consideration and a very potential candidate for being the right answer. But I want to go through the remaining options as well, which produce translation motion but not rotational. So couple does produce the rotation motion. We relate the examples such as steering the wheel and these kind of examples with the couple, and in that, yeah, A should have been the right answer. Let's take a look at the next one. We need to find the value of W, and it is a uniform beam, means the weight of the beam would be exactly in the middle point. So I can draw the line of weight pretty much at the midpoint. What is the midpoint? Midpoint is at a total distance of 1.5 from the starting point. So from here to here, the total distance has to be 1.5 meter. Okay, so ये आपका 1.5 meters होगा. So okay, let me write it. This would be 1.5 meters. Okay, so we need to find the value of W. This is your pivot. We can apply the principle of moment. Very easy question. So what we do is W, this force, times the perpendicular distance of that force from the pivot, which is 1.0. You don't even need to write it, but let's do it anyway. Any other force that would rotate it clockwise, anti-clockwise, no. So let's proceed to the clockwise moments, which is the weight of the beam, and the weight of the beam is 50 Newton. Okay, it is given in the question. So this force represented by the blue line, which is the weight of the beam, is 50 Newton. So you write 50 here, and what is the distance of that force from the pivot? So you're very susceptible to make this mistake. Don't consider 1.5 meter as the distance, because we need to find the distance of this force from the pivot, not from anywhere else. So out of 1.5 meter, you have 1 meter on the left side, and what are you left with? You're left with half a meter. So 0.5 you write over here. So 50 times 0.5 would be 25. So for 71, A has to be the right answer. Alright, then we have a next one question. Which of the forces act only as a couple on the circular objects? So the forces have to be opposite. In the option B, the forces are opposite, but they are not equal in magnitude. So C is out the window. B, the forces are not even opposite. D, the forces are perpendicular. A, the forces are opposite, the forces are equal. They are not acting on the same point. They're not passing through the same point. So it is satisfying all the conditions. Then we have the next one, which expression gives the torque formed by the couple. So for the expression of torque formed by the couple, you write down the formula that torque formed by the couple equals to one of the forces times the perpendicular distance between the forces. For couple, we take the distance between the forces, not the distance of a force from the pivot. For couple, we take the distance as distance between the two forces. Always keep this in your mind. Perpendicular distance between the two forces. So one of the force is this way, the other force is this way. The perpendicular distance between these two forces is not x, it is y. You see, perpendicular sign. So it has to be f times y. So for 73, we have B as the right answer. So here we have. We need to find the mass of the meter rule. So it is a uniform meter rule, so mass would be exactly in the middle point. I can call it M2. This is the first one is your M1. So we'll be applying the principle of moment in terms of the masses. Okay, you can also apply the principle of moment in terms of force, but you can also apply in terms of mass. we prove it in a way that force equals to, in this case, the force weight equals to the product of mass and the gravitational field strength. So on both sides the value of G would be cancelled out and the ratio would be same. So you can apply in terms of mass. We need to consider pivot. We can consider this point as a pivot because in that case the force, the tension in the string would be passing through the line of pivot, and hence this force would not be able to produce any moment. So we will not be even considering it in the calculations, and this is the only smartest way to get rid of this force. अब ये आपकी कैलकुलेशन में आप यूज़ करोगे, then the perpendicular distance of that force from the pivot has to be 0 and the moment would be 0. So it's better you don't even consider it. So we have the first force, mass 64, times the perpendicular distance of that mass from the pivot is from 4 to 34 would be 30, equals, the other one is m2. We need to find m2. We write it down as it is. So from 34 to 50. So you hit it on the calculator. 64 times 30 divided by 16. So for 74, you'll be getting C as the right answer. Alright, so here we have the next one. So this is your pivot. The object is in rotational equilibrium, means the moment of force clockwise, the sum of moment of force clockwise equals the sum of moment of force counterclockwise. We need to find the magnitude of force F. Okay, so that's it. That's an easy one. So all we gotta do is apply the principle of moment here, and we can then easily find the value of this force. So let's start off with this one. First of all, you see the last force at the bottom, you can ignore this force because this is a force that is passing exactly through the pivot. So the direction of this force is this, and the same one is the line of pivot, hence there is no perpendicular distance of 4 Newton force from pivot. ठीक है, इसका perpendicular distance आपका इस तरह से होता है, if the 4 Newton force would have been acting over here or over here, then you would have said this is your perpendicular distance or this is your perpendicular distance. But we have no perpendicular distance of that force from the pivot, so we can ignore it out of the calculation. We are left with this one, which would rotate it anti-clockwise. This one would move it clockwise, and this one would move it anti-clockwise. But for the force of 2 Newton, this one, we don't have the perpendicular distance of that force from the pivot. We can split it into components. We have done it many times. One of the component would be over here, which would be 2 times cos 30. The other one would be upward, which would be 2 times sine 30. So 2 times sine 30 would be 1. You can hit it on the calculator. It would be 1.0 Newton, and that would rotate it anti-clockwise. So what do we have for clockwise? We have F, or uska perpendicular distance of 5 equals 3 Newton, and the perpendicular distance of that force is 2. So 3 times 2, 3.0 times 2, plus this one 1 Newton times 4.0 times 4. Then we can simplify it. What do we get? 6 plus 4, 10. 5 divided on the other side, and we get 2 as the right answer for this one.